Good morning. As mentioned in part one, as you can see, this is part two that we will be tackling today in plumbing in Dolomite land and create some awareness around plumbing in that areas. In part one, I did mention I'm not a geologist and I'm still not a geologist, but what I want to state is that I understand the power of water, what those effects are on soil erosion, and if you've got poor infrastructure, what those effects can cause. In part two, today's session, I hope to demonstrate the importance of good plumbing in these kind of dolomite areas, especially if you're in an area where there is dolomite. Not every area has dolomite. The dolomite is covered in SANS 1936. I just want to mention that's the standard that governs and talks to the development and infrastructure around dolomite land. It is a very, very large standard. It covers a lot of information, and in today's tech talk, I'll touch on some preferred types of pipes that they recommend for water supply in the various categories of dolomite, being D2 and D3. Just before I do kick off, I think what I should do is just to quickly just recap on part one. In part one, I spoke about what is dolomite, and as I'm going to touch very high level, it's a carbonate rock. It's made up of a mineral called dolomite. It's relatively impervious. It's insoluble in pure water. The little picture that I put up in my last session shows a lot of those blue little lines that you see there are like fissures and cracks and joints, and that's basically, it's natural. It happens and acts as passageways for water to ingress into the soil and to get down to the water tables. Over time, that dolomite does dissolve, and basically it triggers things such as little dough lines and basically sinkholes. I also spoke to you about the various categories of dolomite. Now, those dolomite areas are categorized on D1, D2, D3, and D4. D4 basically being the top end of the risk scale, and additional site special precautions need to be taken if you're working in that kind of area. And then D1 obviously be on the lower end of the scale. These kind of designations are done through professional geotechnical engineers who conduct special investigations. They look at a lot of data, and basically they then come up with those kind of categories and allocations of categories. As mentioned, the SANS 1936 consists of 4 parts and basically covers part 1, basically works on the general requirements, part 2 and 3, construction of buildings, the infrastructure. Part 3 is where we basically come into play when it talks more about the infrastructure around buildings. That infrastructure means, waterways, sewage, water pipes, those kind of things. And then part 4 of the standard basically speaks to the risk management and the continuous risk management of those kind of areas. I also spoke to you, or mentioned, that 96% of sinkholes and subsidence basically occurs through where man is involved. And I once again just put the picture up there just to remind you that wherever man's involved, we either digging up or making dams or drawing water out of the below surface. And as infrastructure grows, you have more digging, more erosion, and eventually, we're dealing with water that starts to dissolve the dolomite at a faster rate. I also spoke to you about engaging with your local authorities to find out if you're in a dolomite area and if there's any special requirements. And I also requested some information as to if you have any information or pictures or videos. And I just want to say to you that I want to actually thank the people that phoned me after the last session. It was awesome to hear your stories, and thanks for sharing those stories and pictures and just the effects of what a leaking pipe can cause. So I remember the one gentleman phoning me and saying that he's in an area near George, and when they were busy with ground zero and all the stress and there's hardly any water, and the guys were just sinking boreholes and boreholes, that at the end of the day he was worried about these sinkholes being formed because your water tables have been dropped. And he was just concerned. And please continuously, if you have anything, please share with me. One of the session in the middle here, I had someone share something from the Western Cape, where it was basically a main line, I think, that burst. And you can see the effects and how quickly this happens, that size of that sinkhole, although maybe not in a dolomite area, but I just wanted to maybe stress the importance of, how how erosive and how quickly water can, create a sinkhole of this nature. And as you can see, it's almost swallowed that car in total. I also had the privilege of going out and personally having a look at some areas where it is in a dolomite area, where infrastructure is fading, and the effects of just on a tar road. As you can see the pictures on the left-hand side, you can see the little dough line that's been formed on the top left-hand side. Top right-hand side, you can see the grass starts to grow, the cracks get bigger, it completely breaks up the tar surfaces. And I've actually got a little video on the right-hand side, which I'd like to just share with you. So just bear with me. It is a very short little clip. I don't want to take up too much bandwidth, but I just want to show you just actually what's happened here. It was a water pipe that's leaking underground. And as you can see, the water is in that area is just saturated. The top section here, I don't know if I can just maybe get it something that I can just use as a pointer. Pointer. Just give me a sec here. Mouse. So on the top section, that's almost like a tar surface, and that's completely eroded away. And as the water is bubbling up, it's pushing up, and the whole area is just saturated. And as you know, water is treated, so you have chemicals in it, chlorine, that kind of stuff. And being in a dolomite area, this will definitely become a bigger and bigger hole or dough line, and eventually possibly turning into a sinkhole. So these things need to be attended quickly. They need to be repaired. We need to look after our infrastructure, and we definitely need to just attend to these things. So if you come across something, you see something happening like this, or if you're a consumer listening, make sure that you report this to your local authority. So as I mentioned in my first session, I'm very close to Midvol. So I've got a lot of information from them. They're in an area where there is dolomite and sinkholes. And if you can see on your screen, the sheer size of that sinkhole over there, and the little guy standing on the side there, it's extremely scary. Can you imagine that could probably swallow a whole house? But once again, I recommend that you engage with your local municipality for guidelines and data. They should have it if they are in a dolomite area. And they've sent this brochure to me. I'm not going to read through every section of the brochure. You're more than welcome to grab a screenshot if you want to. I'll touch on a few points. For example, we'll start on top here. It says make sure that the boreholes, so these are just general guidelines that they give to people in the area. They say that if there's boreholes, make sure that they're at least situated 50 meters away from a house or a dwelling or a workshop. They say make sure that, if there's anything that stands out, cracks maybe on a house that are showing, please report those kind of things. They say arrange for pressure pumping and test. If you have a borehole, have it tested. I had a long thought about that, and what I eventually found out is that if you've got a pressure pump at the bottom of a borehole and you're pumping up and you're opening a tap at a very slow rate, as an example, that there's still pressure in that pipe section between wherever, if it's 15 meters deep, 20 meters, 100 meters deep. So what you don't want is that pipe has leaks or cracks. So as there's pressure being put and the pump's trying to push the water to the top surface, is that it starts to leak in that pipe, and that pipe then causes erosion. Obviously, no one knows and no one can see, but only through maybe a pressure test, you'll be able to determine, wait, there's a leak and we need to attend to it. Obviously, you don't want to have erosion happening around that pipe. It could be a very huge section that is eroded away, and you'd be sitting on some huge dangers there. I see there's two little arrows, and I just want to draw your attention to this. And I'll read this section to you. So it says, when carrying out building operations, such as new buildings, make sure that all the building works comply with the new regulations governing building in dolomite areas. So guys, if you are in the area and you're doing infrastructure, just be fully aware that am I working in a dolomite area? Am I not working in a dolomite area? And then engage with the local authorities on that. The bottom section there, it says, make sure that all wet connections to buildings, houses, workshops, storage facilities are properly joined using approved plumbing infrastructure and methods. And we'll be talking about some of those. Like I said, I'm going to share a table with you that I found in the standard, and I'll just touch on a few pointers on that as well. It says clearly, make sure that there are no leaks. So it tells you should be checking. You must make sure, because as we know, a leaking pipe, leaking infrastructure leads to these kind of dough lines and dolomite and sinkholes being formed. And it even says it covers taps, drains, cisterns, pipes on the inside of the buildings as well. What I thought I'd do today is I'd look at SANS 1936. I'd look at specifically Table 5 and share with you some of those types of materials that they would require in a bulk for bulk supply. But before I do this, let me just try and quickly explain the table to you. So on this side over here, under 1, it says the application. So you'll see it says bulk supply, outside diameter equal to or greater than 300 millimeters. And then obviously the 2 pipes, materials that they would accept. Basically, if we read the top of the table, it says preferred pipe types for use on site, designated as D2 or D3. What is important is that it's not categorizing D4, as I mentioned to you in the first session and in the start of this session. You know, D4 has some very special requirements, and it's a high end of the risk scale. So the next column is basically the minimum pressure rating or ring stiffness that they require. So this is the minimum. And then when you do read the minimum pressure ratings, the point that I do want to make to you, you'll see, for example, here's class 12, under class 12, and it says A and B. So always read, if there's an A or a B or a C or D, just read it with a ledger for guidance as to how you must read that class 12. So I'll give you an example. If it says class 12, A and B, so if I read B, it says on sites designated as D3, Dolomite land, the nominal pressure rating shall be 1 pipe designation or class higher than which complies with the above requirements. So guys, just read it very, very carefully and don't miss out on reading it with the little ledger at the bottom or the additional information. The applicable standards that are applied that also need to be taken into account, how the pipe joints should be joined together. So we'll touch on that as well. Guys, I know it's a lot of information, but what I have done is my next 2 or 3 slides, I've tried to make it easier. I've condensed this just as like a bit of an overview, so it's easier to understand. And then additional requirements and comments that need to go with that kind of pipe size. So let's have a look at a few things on the bulk supply. There is steel pipes are allowed. Obviously, there's mentioned that it must be done in accordance with the design requirements. So whoever's done that design requirements, we're talking about a competent person that would design it. There may be some special requirements, specific sizes. So just to bear in mind, it has to be done in accordance with those type of design requirements. The pipe joints, it says here, and I've just circled in red just to highlight it, must be continuous butt, sleeve or socket welds. You may not use screw joints. It says it may not be used. And mechanical joining devices, those flanges, and if they are used, it should be only used in manuals. Now, guys, just when you read mechanical joining, for those that don't know, think about things where you need to fasten things, bolt, nuts, flanges, that you can't put in the ground and cover it up. Makes perfect sense, especially if you're dealing in dolomite areas. The additional requirements for steel pipes would be that you need to make sure that they're protected against corrosion by means of, either being galvanized or some coatings of that on that, and where required, also cathodic protection. Only way to try and explain that is similar to a geyser. You've got an anode, it's seen as a sacrificial anode, and basically it's placed in the ground, and basically what happens is that the anode would then sacrifice itself, and in such a way would protect the pipe from corroding at a slower rate, in other words. Under bulk supply, we also got high density, HDPE. PN, and I just want to maybe stop on this. So you'll see that the minimum pressure rating says PN, and then you'll see at the bottom here, you get class. Now, between PN and class, my understanding it's exactly the same thing. So if you see PN 8, we're saying a pressure rating of 8 bar. And if we're saying class 12, we're talking about 12 bar. So basically almost means the same thing. Let's quickly just have a look here. So you might be asking yourself, well, what does PE stand for? Now, my understanding is that the PE is basically the material that's used. You may have seen that there's sometimes a thing called PE 80 or PE 800. I think you probably get some higher values as well, but basically it's just the long-term strength of the materials that they use. So let's have a look. So with HDPE, yeah, they're saying that butt welding needs to be done in accordance with the relevant standard, which is 10268, and mechanical joining, once again, shall only be done or only be used in manuals. Guys, you'll see a common thread on the additional requirements and comments, and that common thread that I want to just point out to you is that they're asking that the number of joints shall be kept to a minimum. So you don't want to have a lot of joints underground, because a lot of joints means possible or potential leaks. Makes perfect sense. The longer the runs, the better. So let's then move on to the outside diameter of 75 millimeter to 300. And yeah, they've got, once again, HDPE. Unfortunately, you can see that the pressure rating does increase to 12.5. Once again, you can use butt welding in accordance with that specific standard 10268. I apologize. And once again, mechanical joining devices and flanges only to be used in manuals. Number of joints, once again, to be kept to a minimum. The other two within this size of pipe that is allowed, or is preferred, should I say, is PVC, which is then obviously modified. So here's two classes that they have put, and you can see it's exactly the same makeup or material. And the one is class 12, and the other applicable standard that governs, or that works with that, is 966 part 2 and stands 1283. What the difference is that mechanical devices consisting of sealing rings and grooves, or both, and clamps are allowed here. But if it's of metal fittings, it obviously needs to be stainless steel. Once again, the longer the run, the better, the less leaks. And yeah, they actually say that the requirement is that pipes need to be supplied in 6 and 9 meter lengths. So don't get there with small little sections and try and join them. It just doesn't make any sense. On the class 12, class 16, I do apologize. Yeah, they're saying that you can use pressed on SG iron, and that's a Vitalic shoulders. I'm going to show you a picture of what that looks like now. And when you see SG, for those who don't know, basically we're talking about like a cast iron, a very strong, protected, almost, I want to say, like a cast iron type of an effect. It's a very robust type of fitting. So, and then anything with a diameter is less than 75 millimeters. The other recommend HDPE, 12.5 pressure rating that it can handle or should handle. And yeah, they say that electrofusion or butt fusion is required. And can you see there's reference to D? Now, D basically, if you read it, and I do apologize, it just didn't come out on the screen. It was not showing nicely on the screen. Basically, electrofusion is basically a preferred. It's actually better. They rather request that if it's in a residential kind of setup or on residential property, that you rather use electrofusion versus butt fusion. But I want to say that it does state both. But the one is just preferred over the other one. Once again, if there's any mechanical joining devices, once again, must be in manuals. The other pipe sizes, they require that it should be supplied in 100-meter rolls. It's a lot to take in, guys. And what I felt I wanted to do was just to try and make it a little bit easier. And I do apologize, and just bear with me. I'm going to show you what I have tried to do to try and create a little bit of an easier way to try and sum this up, but always refer back to the table for final stuff. I've basically put it as bulk supply, 300 millimeters, and I've broken it up into, so there's steel pipes that are allowed and HDPE. Let's just quickly run through it again. So you need to follow the design requirements. It can be butt, sleeve, socket welded. No mechanical joining devices unless it's in a manual. No screw joints allowed. And remember, you need to protect the steel pipes against corrosion, galvanized, that cathode protection that I spoke about. On this pipe size, on the HDPE, let's run through it again. Minimum pressure, a nominal pressure of 8 bar, or the design requirements, whichever is higher. So if the design requirement says you need to use it 12, then obviously you work with that. And I put a little question mark for you guys. So those who are just taking a screenshot here, just remember that if you are working in Dolomite Land 3, ask yourself the question, oh, it is Dolomite Land 3. So what I need to do is remember that I need to just size up to one class higher. Here I'm only allowed to do butt welding and no mechanical devices unless it's in a manhole. And I just want to say that I have looked up the definition of manhole, and that's in SANS 10400P, can be found, and it does say a manhole or inspection chamber. So just check with your local council that that you could, if you're going to be doing those kind of joints, that it is in that it's allowed in an inspection chamber. And then remember, number of joints, please keep them to a minimum. The less joints, the less likelihood for it to leak. All right, then let's have a look at the outside, the modified PVC and the HDPE. Remember, this is on a supply where the outside diameter is 75 to 300 millimeters. And once again, design requirements, and let's start at HDPE 12.5, or the design requirement. Ask yourself the question on that Dolomite Land 3, if you need to upsize. Yeah, I can only do butt welding on this type or this size of supply pipe or a water pipe. And then if there is any mechanical joining, guys, remember, only allowed in a manhole. Number of joints, once again, please keep it to a minimum. And then what the standard also says, it actually says to you between 75 and 90 mil, the pipe's roll should be supplied in 100 meter lengths. And if it's 110, they come in 50, minimum of 50 meters. On the PVC side, it was broken up, if you can remember from the table, into a class 12 and a class 16. Once again, those key points just need to be asked. Do I need to size up or do I not? The picture I wanted to show you on the mechanical device consisting of a sealing ring and groove, and that's a cut through, and you guys can see there's like a ring, and there's those grooves that they're talking about. So that's that you could use. And remember, if there are any metal fittings and you're placing it underground, guys, stainless steel within Dolomite areas, or any other special requirements that may be required by the relevant standard or the relevant municipality. Once again, pipes needs to be supplied in long lengths, as mentioned, the longer the better. On the class 16, remember, yeah, you can use pressed on SG iron vitalic shoulders, and that's a little picture of what it does look like on the side. As I said to you, that SG iron it's like ductile iron. It's treated. It's very long lasting. It's not like a standard steel that would corrode faster underground, as an example. And then my understanding is that these vitalic shoulders, so because there's a rubber ring in the inside, that it does allow for a little bit of movement, which is probably needed if you're underground in an area where there is this leaching and a bit of movement. So I hope that picture gives you a little bit of an easier overview of table 5. I really hope that you can see that the importance, that of no leaks and quality plumbing is key. Guys, same here on the HDPE 75 and smaller. The importance is, once again, ask yourself, am I working in a higher category Dolomite area or designation? The little yellow section that I've highlighted here on residential land, the pressure rating shall not be lower than, and guys, please take a note of that, of 16. And that is a reason because, you gardening activities, so you want a bit more of a bigger pipe, and that please make sure that if you are working on residential land, it has to be PN 16. Butt welding or electrofusion is what is required. And then I just want to make a note here, or you should just try and make a note on your side maybe. Small diameter pipes must be preferably joined by electrofusion instead of butt fusion. Pictures on the right is showing the electrofusion, where they put a charge in, it heats it up, and it seals, and it almost welds the pipes together. Picture on the right-hand side is where I'm holding a section of a section that has been electro fused, and you can see those little points, the little coils on the left-hand side. That's what heats it up and joins the pipe together. Once again, no mechanical joint devices or flanges. If it is in a chamber, as an example, or forgive me, please, I'm trying to go a bit fast now. And then pipes need to be supplied in rolls of 100 meters. And that brings me to the end of my session. I want to say thank you very, very much for making time this morning to listen to me.